Right, good morning everyone. First day of Dreamforce. Great to see so many people here, and it's really nice to do a talk on the first day in the morning because everyone's still awake as well. And people are a normal color rather than kind of gray and green, and gradually flagging at the end of the week. So welcome to this talk on unit testing Lightning Components with Jasmine. So my name's Keir Bowden. I'm also known in the community as Bob Buzzard. I'm the CTO of BrightGen, who are a Platinum Cloud Alliance partner in the UK. I'm a Salesforce MVP, so I do quite a lot of this sort of thing, talking to people about coding on Salesforce, and I'm also a Salesforce certified technical architect along with quite a number of other certifications which I haven't put on here because it'd be a bit boring to go through them. So first off, I thought I'd just talk a little bit about why we write unit tests. So the reasons to write unit tests, it gives us confidence that our code works as expected. Doesn't necessarily mean it works properly, it just means it's doing what we expected and hopefully that's what the customer wants. Biggest thing for me with unit tests is it reduces the cost of bugs. So the earlier you can find a bug and the nearer to a developer you can find a bug, the cheaper it is to fix. If you find it in development, then you just maybe refactor the code, write a couple more unit tests, and then you're done. If you find it in production, it typically has to be reported somewhere, it has to be logged, it has to be triaged, it has to go back to R&D, they have to do development, has to go through QA, UAT, yada, yada, yada. So there's like a whole load of steps, each of which introduces a time and a cost, which is never a good thing. Typically, if people know they're going to be writing unit tests, they will produce testable code because you don't want to write code that makes your job harder to do in terms of writing unit tests. So it tends to be a bit of a virtuous circle, and test-driven development is a kind of extreme example of that. And unit tests also promote refactoring. So I'm sure many people here have been developing somewhere where nobody really knows exactly how the code works. There's no unit tests for it, and everyone's really a bit scared of touching it because you don't know what you're going to break. There's no way of knowing that fixing that bug might have some side effect here, so you end up with a lot of kind of bags put on the side of it. Whereas if you've got good unit test coverage, especially of your sort of external contracts, then you can refactor, run your unit tests, they will pass. You know you're in pretty good shape. You haven't broken any of the previous functionality or the pre-existing functionality. You've only changed what you wanted to change. So there's a few challenges around JavaScript testing on Salesforce. Probably the biggest one for me is that there's no test context on the client. So changes aren't rolled back. So if I insert a record in JavaScript under test conditions, that's actually going to go into the database, which is fine in my dev org and it's fine in development. However, if you run those tests in production, that could kick off all sorts of mayhem downstream. That could be, you know, integrating into finance system, it could be generating invoices, and you could end up with a lot of red faces. So that's one part of a challenge. The other thing, there's side effects. So as your JavaScript typically has some side effects. So when you run a test, that may go off and do some manipulation of the DOM. It may trigger some server-side actions. And I think at the moment, probably the biggest reason people aren't doing JavaScript testing on Salesforce is you don't have to. If you're writing Apex, the Salesforce platform makes you write 75% test coverage before you can deploy to production. You've got nothing like that in JavaScript in Visualforce or in Lightning Components. And probably the reason for that is that your JavaScript runs on the client, so it's not stressing Salesforce servers, so if you've written bad code, you know, why do they really care? One reason, to my mind, they should be caring is that if I've written a Lightning component that drops into a standard Salesforce page, and that just kind of melts things and chews up all the CPU, makes it hideously unresponsive, no one's really going to look at that and think that's my Lightning component. They're just going to say Salesforce has stopped working. So I think that over time, I hope, they will start enforcing some test coverage on the front end in JavaScript. Not that I know that anything like that is going to happen, though, unfortunately. So some techniques now for writing testable JavaScript code. So use unobtrusive JavaScript. So don't place your JavaScript in handlers attached directly to DOM elements, because then the only way you've got of testing that is actually to make that action happen against that DOM element. And avoid anonymous functions. You can't test those in isolation. You have to execute the actions. Here's an example of an anonymous function. This is from a Lightning component, so I create a server-side action, and then I set my callback, and I've got an anonymous function which processes the result. So the only way I can test that anonymous function is by actually carrying out the server-side action and getting a response and processing it, which is not necessarily what I want to do, because I don't want to hit the server because I'm running in a test context. Another technique for writing testable code is to decompose functions. Often you'll see a function which gets past some parameters, decides on some action to take, and then takes that action. When you're writing testable code, you really want to decompose that into a function to decide on an action, and then another function to execute the action. Now, I realize this might sound like overkill. However, if you look at this particular function, so this is basically doing a redirect based on the URL that is passed. If it's a relative URL, it's going to carry out that redirect. So if I call this in a test context, then that redirect happens. My tests stop, my browser has gone off to a different page, and no one's really got any idea what happened there. So a better way to write this would be to have a first function which determines if there's a redirect, and that returns true or false, and then I can pass that, I can look at the result of that, and then I can pass that URL into the do redirect function only if I need to do that. So in this case, I can't test the do redirect because that will happen, but I can test the is redirect. So I can test my business logic that's deciding on the actions to take, and I've decoupled things. So what I'm going to do today is kind of walk you through a bit of Jasmine, then I'm going to show you a demo app. So this is a little flavor of what the demo app is. It's a simple job listing board. You've got the jobs down the left-hand side, some search capability down the right-hand side, and these are two separate Lightning components that handle the list and the search. They're decoupled from each other and they communicate via events. So this is available at a GitHub repository with the short link there and also with the QR code. I've just noticed my timing isn't working if the technical person is here, so I don't know how much longer I've got to talk. So don't worry about capturing this information. I'll share this deck out on SlideShare, and that's got all the links, etc. Okay, so let's talk a bit about Jasmine. So Jasmine is now my unit testing framework of choice. So I've been doing this talk in a couple of different places over the last year, and I was a bit more focused on QUnit with sign-on. And Jasmine actually encompasses both aspects of QUnit and sign-on, which I'll talk about in a minute. But also what I like about Jasmine is it plays quite nicely with the Lightning Locker service, which is fairly important at the moment, and come Spring 17, when it's turned on, will be really important. So Jasmine is a pure JavaScript unit testing framework. It executes in browser, so you can execute your tests from anywhere. And this is really useful because your Lightning component JavaScript is only executable from the browser because it needs to be running inside the Lightning components framework. I mean, I guess you could MacGyver a kind of framework of your own on your local machine, but typically you want to run it in the browser with the whole Salesforce framework behind it. Jasmine's open source, so there's a short link there. Again, don't worry about capturing it. I'll post the slide deck. But it's open source, so you can go in and look at the code, which is actually quite good because there's not a great deal of documentation around about it. There's quite a decent book, and on the deck that I won't cover it now, but on the deck that I put up on SlideShare, that has details of the documentation in the book. And as I say, key thing for me, only minor changes to get it working with the Lightning Locker service, whereas when I tried QUnit, I had quite a lot of issues, and I just kind of lost interest. I was having to change so much of it, it seemed like there was no real benefit to it. So Jasmine is a behavior-driven development for testing framework, which is the given, when, then concept. So in my job application, given that the job page is open, when the user searches for jobs, then the search method should be invoked. So given, when, then, you don't really see an awful lot of that around the internet, but it's a very familiar pattern of setup is given, exercise is when, and verify is then. So here's an example of a small Jasmine test. Don't worry about the exact details, so I'll describe those in a minute. But I've got my setup, my before each, I've got my exercise, it should do this, and I've got my verify, I expect this to happen. So, features of Jasmine. You have suites, which I'd imagine anyone who's been doing unit testing outside of the Force.com platform up until recently is very familiar with. It's a collection of tests. So a suite is defined by the describe function. So you describe, you give it a name, and then you have a function, an anonymous function, entertainingly enough, which you shouldn't use because they're difficult to test. But you have an anonymous function which then contains all of those tests that are going to run in a particular suite. And then within that, you'll have specs, as Jasmine calls them, which are your individual tests. So in this case, it gets the skills, and then there'll be a function which actually does the testing. And then you have the expectation, the verification. So anyone that's written Apex unit tests, this is the equivalent of the assert call. So it's the expect function, and you can also chain this with a matcher function. So a matcher function is anything which verifies behavior. So what I've got here is expect, and So I've got my expectation. Self.getSkills is the thing that I apply it to. I'm expecting the self.getSkills method to have been called once. And then my matcher is to have been called times 1. So there's loads and loads of matchers already available in Jasmine. And also you can write your own custom matchers if you have particular requirements. So Jasmine also has set up teardown capability. So you can do this either before all of the tests in a suite or before each of the tests in a suite, or if you need some setup teardown functionality on a specific test, you just put that inside the actual test spec itself. So there's an example of a before each of one of my tests, and I set up a spy on a method from my particular object that I'm testing. So a spy, the concept of that is it stubs out a function, so it replaces the function with some Jasmine auto-generated code, and it can do things like track the calls, track the arguments, or you can turn it into a full-featured stub, in which case you're basically saying, when this is called, I want the Jasmine function to then return this particular value. So it's a way of being able to inject test data and almost turn it into a mock. And in JavaScript, because each function is a first-class object, you don't need to mock out a whole object. You can just replace individual functions, just swap those in and out, which is quite nice if you come from an Apex background, like I do. So spies, just to go into that in a little more detail, try and make it clear. So here's an example. What I'm going to do is I'm going to spy the this.getJobs function. So this is my doSearch function, and what that does is it goes off and gets the jobs based on the skills that the user has defined. Oh, sorry, one too many there. So as you can see there, I've got my getJobs function. It sets up an action, enqueues the action, goes off to the server, and gets the jobs. And that's an example of something I don't necessarily want to happen. I don't want to make server-side calls if I can get away with it. So what I then do is I tell Jasmine to spy on the getJobs. And what that means is that next time I execute this.getJobs, rather than hitting the function on the top right, I actually hit this new Jasmine spy code that's been put in place that's replaced my function. And that will just record information about how it was called. And then while that spy is still in place, I can then interrogate that spy and ask it what happened during that test. So in this case, I'm expecting it to have been called 1 time. So that's my expectation, that will verify. If it's called more than once or it's called 0 times, then the unit test will fail. So it allows me to check that my logic, which should trigger that server-side call, executes correctly without me actually having to execute the server-side call. And this is reset whenever the spec or suite completes, so you don't have to do any teardown of that. As soon as you exit the function that you're in, Jasmine will reset everything to how it was when you started the test, which is obviously very important because you don't want run-on tests that rely on what's been set up on previous tests. And the next thing that I'm really keen on in Jasmine is the concept of reporters. So things like QUnit, test frameworks like QUnit, the way they work is they really just want to write to the DOM. They want to write out the output with a particular styling, and that's really what they want to do. Jasmine decouples that quite nicely, so it allows you to define an object, and effectively that gets callbacks when things happen that Jasmine has recorded. So for example, things like, Jasmine has started, a spec has started, a spec has completed. And there's an example of a very cut down reporter, so you don't have to, it's not like it's a big interface you've got to implement. You implement as many functions as you want, and if there are things that Jasmine is doing as part of the testing that you don't really care about, you don't want to report on, just don't provide a function and you won't get those. This is very poorly documented by Jasmine, the reporter, sadly, so you have to go digging around in some of the example code to figure out what's actually going on there. So there is an HTML reporter included in Jasmine, but in the GitHub repository link that I've put up, the Jasmine in the static resources, I've disabled that because I wanted to do something different with it. I wanted to replace it with something that is styled with the Lightning design system. There's also a console reporter, which will just output text of, this test started, this test stopped, into the JavaScript console, but that's been deprecated. So I don't know why. I've seen no sign that anyone's going to replace it. It just seems like it's going to go away at some point in time. So let's talk a bit about testing Lightning components. So one of the things I had to do in order to get this working with the locker service, I had to delete a few lines of code from the Jasmine JavaScript. I didn't have to do an awful lot, to be honest, but I had to knock out these 4 lines of code. So most JavaScript unit testing frameworks want to replace things like set timeout, set interval, clear interval, because they want to manage it themselves. They don't actually want to have to wait 200 seconds if that's what you've configured in order for the timeout to happen. And in older browsers, you'll see this again quite a lot in JavaScript frameworks, in older browsers you have to kind of replace the function with itself to make it writable for some reason. However, if you try this in the locker service, that will error because you don't have a window, you have a secure window, and those methods aren't writable. So in the version of Jasmine in the GitHub repo, those are just commented out. They're still there, they're just commented out. The other key thing that the locker service introduces, so my original version of this before the locker service, I was doing a lot of stubbing out of the Lightning component framework, things like component.set. And when I try that with the Lightning service on, I get a lovely error saying that nothing's writable anymore. So you can't spy on framework methods, so what you have to do is effectively isolate any calls to the framework that you would want to stub out so that you can stub out the method that encapsulates it. So you need to decouple your code an awful lot from the framework as much as possible. Okay, so this is probably the key slide for unit testing Lightning Components with JavaScript, what I'm talking about today. So if you don't pay any attention to any other slides, which is fine, this is probably the one to take notice of. So here's my key players. I've got my test application, which is a Lightning application which encapsulates all of my tests. I've got one or more reporter components. In my example app, I'm only using a single reporter. I've got one or more testable components, which are the things that I actually want to run the unit tests on. And then I've got Jasmine sitting down at the bottom. So if you look in the key, you'll see as well as the Lightning components in Jasmine, I've got 3 different sort of types of interaction. So I've got a Lightning event, which means I'm actually creating an event, encapsulating it, sending it off. It's actually registered. And I've got an attribute change effect where I don't actually need, so event rather, where I don't actually need to create the event or anything like that. I just change the attribute, and then whatever is listening for a change event on that gets notified that has happened. And also I've then just got a regular JavaScript function because Jasmine is attached to the window object, so I can actually directly call JavaScript on the Jasmine object itself. So this is kind of the way that I trigger the test. I'm sure there are other ways to do this, but this is the way that I've found that works best for me and kind of decouples things from each other quite nicely. So what happens first is the test application creates an instance of Jasmine that gets attached to the window, so it's available to all of my other components in the same space, same namespace. Because the same namespace means you share the same secure window with the locker service enabled. So I then fire off an initialize event. So this is an event that I've created as a custom event. I fire that off to each of the reporter components and tell them to initialize themselves, tell them to do what they need to do in order to start recording Jasmine information. So what they do is they register themselves with Jasmine, and then once that's successfully happened, they fire an event to say they've initialized. What this means is that my test application doesn't necessarily need to know how many reporter components there are. It doesn't need to know which reporter components are there. It just knows how many there should be. It knows they've all initialized. It knows it's ready to move on to the next step. So the next thing it does is it asks all the testable components to enqueue their tests. So the way Jasmine works is when you define your tests, they actually get sort of queued in Jasmine, but they don't get executed until you make a request to execute those. So again, slightly decoupled from each other. So all of my testable components get told to queue their tests. They all make calls out to Jasmine to say, here's a test, here's a test, here's a test. And then when they're done, they then send another notification back to the test application. So again, the test application knows how many are there, doesn't have to worry about which ones they are, just knows there should be 7 components getting tested, therefore I'll wait until 7 of them have come back, and then I'm good to go. And then finally, it's not finally, so the next thing that happens is then it asks Jasmine to execute the unit test. So this is the point at which the unit test will actually happen and action will take place. As Jasmine is executing those unit tests, what it then does is it notifies the reporters that things have happened. I've started a spec, I've finished a spec, there was an error, here's the stack trace. So it passes all that kind of information on. When all of that's done, the test application then notifies the reporter that they're complete. And the reason that I kind of separated out so the reporters capture the information but don't do anything with it until they're told to was because as well as outputting to the screen, I want to post a chatter and things like that. So I want to make sure I post kind of the overall result rather than keep chipping away as things go on. So I realized I talked a lot there, but in the deck on SlideShare, there's a couple of additional slides that explain all of these points again, hopefully in a bit more detail. So have a look at that. Right, so now I'm going to flip out to my demo and show you my application. How's that for size? It looks a bit small. Okay, not too bad. Okay, so as I said, job listings on the left-hand side, the default behavior is to go and get all of them from the server and then a search box over here. So I can limit that to Apex if I want, and that then reduces it to senior developer and tech lead, or I can type in prints. No, I haven't got any matching jobs. Actually, let's just type in lead. Yes, that brings me back anything. So seed developer and technical lead. That brings me back the right jobs for that. And when I click the X, that clears it. So as I said, these are two separate components. So the job listing doesn't know anything about the search. It just gets notified that here's a list of jobs that you need to display. So they're not very tightly coupled to each other at all. So let me just bring up the developer console, and we'll open the test application. So here's my test application. Initially, it does nothing. It just loads the Salesforce Lightning Design System, puts out a header, and then there's a couple of buttons on the top that allow me to choose how I want to run those tests. So the initial and obvious one is the Salesforce Lightning Design System table. So that's basically, there is a reporter there that is capturing this information, and then when it's complete, it writes out a nice big header of whether it was successful or not, and then it puts out a table with the results of the individual unit tests so that I can see if there were particular problems. But it doesn't have to go out to the screen. I know that typically unit tests do go out to the screen, but it doesn't have to happen. So here's my chatter feed, nothing in there at the moment. So I can go back to my unit tests, and I can click on the chatter. That tells me it's posting. Now it's posted. If I go back and refresh my page, you can see that I've got a chatter post telling me that the unit tests have passed. And I've also got a link that allows me to open the page, run the SLDS by default, and show me the results of what's actually happened there. So it's a good way of allowing me to drill in. So really, the reporters, you're only constrained by your own imagination of what you actually want to do with those. So I'm going to probably be hooking that into our Slack channel on my project fairly shortly, so that every night I have automated unit tests run around our JavaScript, and then post the results so that every morning we know where we're at. Right, so that was the demo. So let's have a little look at some of the Jasmine code. So this is inside my job list helper. So this is the component that's actually receiving a list of jobs to display. It doesn't do any interaction with the server. That's all down to the search side of things. So first thing I've got a suite of tests called receive jobs. And one of the things I'm doing here is I'm actually creating a set of mock jobs because I'm not going to go back to the server, so I want to inject some mock jobs of the format which all of my other code is going to know how to process. Another thing that I've done that's quite interesting, I couldn't really figure out how to explain, so I thought I'd just show it to you, is framework events will often be expecting a component and an event, but it doesn't have to be an event that's come from the framework. All the event needs is the appropriate function, because this is all JavaScript. So as long as you've got a function with the appropriate name of get parameter here, then I can just inject that in as an event. I don't have to create any kind of Lightning event. It's just a regular JavaScript object. And having created that, what I can then do, I don't have to write any code to say this is a test event, so when it's executed I want it to do something. I can just rely on Jasmine's spy and stub functionality. So as we see here, I can just spy on the event.getParameter method and say when that happens, so .and.return value kind of makes it into a stub, and I say whenever that's called I want to return the test jobs. So I haven't had to actually build those test jobs inside that function. I can just wire them together through Jasmine. So then I have my test that it should set the jobs from the event into the component. So I then execute self.receiveJobs, and then I can expect the event parameter. So I've executed my test there, and now I can go and verify the behavior. So what I've got here is I expect the event getParam to have been called once. So that's my stubbing. However, because I've then actually pushed this into the appropriate attribute, because I don't have to stub everything, otherwise I'm not really testing my code, I would actually expect my job wrappers to have been set in as a component attribute. So I can check that. I can do component.get v.job wrappers. I can say I expect it to be 1, and I expect the name of the first job to match the name of the first job from my mock job list with the name of test. So that's on the job list helper. That's only got the one type of test. This is then my job search helper, so this does a little bit more. It has the capability of doing a search. It has an initialization function where it's not passed any parameters, and it just goes. It has the concept of clearing a search as well, so clearing down when I clicked the X button. So here's an example here you can see of me notifying that the tests have been added to Jasmine, so I just build a test result event, and I send that back to the test application to say that I've successfully added my tests. You can execute them whenever you've heard from everybody else. So again, in the test do search functionality here, another suite, describe, run search. I've got a bit of setup here, so before each test, I want to set the search string to be unit test, and then I want to spy on the get jobs, because again, I don't want to go back to the server. So I then have a couple of individual tests there. The first one to say that it runs a search, so it executes the self.do search and then confirms that self.getJobs has been called at least once. And I've got another one which shows a progress spinner. So what should happen is when someone searches for something, it should get the Salesforce Lightning Design System spinner. So I can test that as well. I expect self.showProgress to have been called that one time. And I've got more functions down here which kind of follow the same pattern. So I won't go into any of them in a huge amount of detail, because you can read this on the GitHub, and there's no point in me boring you with all that. So this is my job test application help, my job test component helper. So this is the kind of the slide that I showed that showed all the interaction between the components and the application and Jasmine. This does the bulk of that. So you can see it's got it's doing it. So once the component is initialized, it will then create this initialized Jasmine Reporter event, and it will fire that. So any Jasmine Reporter listening for that will do its thing, and it will come back and say, yes, I've done. And in that case, I will get notified through the Jasmine Reporter initialize function. So then I'll say, do the tests. So again, do the tests. So I've got an attribute where I say how many tests have completed, how many of the testable components have come back to say their tests are completed and queued. Then I execute the fire, and I notify all the testable components, queue your tests, and then they all come back to me with events, and each one of those events I get, I process the result. So I either get the completed attribute, I increment it, and I say, does that equal the number that I'm expecting? I'm expecting 2 here. If I do, then happy days, everyone's set up, everyone's queued. I can now execute the Jasmine. So then going into execute Jasmine, just getting the Jasmine environment, that basically pulls the object from the secure window. And then env.execute is all you do to get Jasmine to execute all of those queued jobs. And that's really all I have to do. And then I just set into the component that I've run the tests. Then I'll just have a quick look at, so this is the Jasmine Chatter Reporter. So this is the thing that posts the results of the unit tests to my chatter feed. Now the way I've done the reporters, as you'll see in the GitHub repository, is all my reporters have the concept that they want to just listen to Jasmine events and record them. So I've got a super component that does that, and then I've got subcomponents which provide the actual functionality of surfacing those results through whatever mechanism, because I didn't want to have like loads of repeated code kicking around. So it's an example of Lightning Component inheritance, if you're interested in having a look at that. So in here, the first thing I do is I check to see, have I got any failures? If I haven't, I set my message to all test pass. If I have, then I'll put the information about the failures. Then I'll build up the link that takes me through to my test application, because I want to make it easy for someone to go and find out what actually failed. I don't really want to put oodles of detail in the chatter feed. I just want this to be a high-level yes or no. And then once that's all set up, then I just execute this server-side action to post the results to chatter. And that's pretty much all there is to that. So if I go back to my presentation. So this is the demo. So the key takeaways for this, I would say, is that front-end code deserves unit tests every bit as much as back-end code deserves unit tests. So you know, I think a lot of people like me who came to originally used JavaScript quite some considerable time ago, more years ago than I prefer to think about. Really what you did then was that was just a way of making things flash and making things go different colors. So JavaScript wasn't considered to be a real programming language. You just did a little hacky thing that made things look a bit different. And that kind of stuck with us over the years. But JavaScript is now, you know, it's a first-class language. It's the future. It's where all the effort is going in things like Lightning Components, the Lightning experience. More and more business logic is moving to the front end because browsers are now more powerful. JavaScript's more full-featured. So you need to approach JavaScript development just like you do any other development. You need to do it properly, and that includes having unit tests. You definitely want to decompose functions. You want to use functional decomposition as much as possible, because that will make the job of unit testing much easier. And that doesn't mean that you want hundreds and hundreds of methods, which I have seen in a book about JavaScript unit testing was saying make every method maximum 2 lines, preferably 1 line, because then they're really easy to test. What you want is you want it to do one thing, one conceptual thing, rather than do one particular, you know, print something, put something out. And you really want to isolate framework calls, because you've got no real control over the Lightning framework, and I would imagine that's not going to get any better. That's probably going to get more locked down as time goes on. All the loopholes will be closed down. So if you're doing something like, if you want to mock out, for example, setting an attribute into a component, then what you want is a method which actually encapsulates that setting an attribute. Then you can spy that, and then you can overwrite it with your own stuff. Whereas if you want to test it and you want to mock it out in some way, but you've got direct component.set calls striped all over the place, you're going to struggle with that. It's going to be difficult to test. And the final takeaway for me is that it's probably not the locker service if you have any kind of issues. So I see this an awful lot because we do quite a lot of Lightning Components development. Once the locker service is turned on, basically that is then considered to be the first port of call for any kind of issues. It's the locker service, turn it off, it's giving us a hard time. And it probably won't be. What it might be is that your JavaScript code isn't strict JavaScript, so it won't pass when strict mode is enabled, and the locker service enables strict mode. So there's nothing you can do about that. You need to fix that. But a lot of the time, it'll actually just be it's something you haven't tested up to this point in time, until you turn the locker service on, and then you just got in and use that. So when the locker service was first enabled, did find a few bugs with it, but I would say for the last probably couple of months, every time it's been down to something that I've done. It just took me quite a while to actually figure out what the problem was. And on that note, that's it from me. So I realise I covered quite a lot there. So does anybody have any questions? Yeah.
How do you decide exactly what to test?
So the question was, how do you decide what to test? In much the same way, to be honest, as I do anything else. There'll be some, I'll normally start off with some key functions with the core functionality. For example, with my search, I probably wouldn't have worried too much about the clearing search. That's a fairly minor function, so I wouldn't have worried about that. I'd have been actually doing the initialization because that's the first thing that someone's going to see. And I'd also be testing the searching. And then depending on how much budget I had left, I'd then be deciding whether I needed to go and test further on that. But really, it's units of functionality you want to test. You want a suite that tests a particular area of functionality, and then you can break that down and add additional specs, additional tests into that. But there's no hard and fast rule. It's I guess if you're from a test-driven development background, then you might want to go that route. I'm not, so I haven't really done that with Java. I don't find that I can work that way with JavaScript because although I've been writing JavaScript, excuse me, on or off for a couple of years, it's only in the last probably 5-6 months that I've been doing it pretty much all day, every day with Lightning Components. So I still don't feel that my JavaScript is competent enough that the first way I decide to do something will be the way that I actually end up doing it. What normally happens is I find a much better way. So I don't want to invest the time in writing huge amounts of test coverage for that if I know I'm actually probably likely to chuck it away or find a better way of doing it. Yes?
How do you load the test data? Do you propose that we should go in the Jasmine framework, or should we load the test data from outside?
So the question was, how do we load the test data? Should we load it through the Jasmine framework, or should we load it through outside? So I make each unit test responsible for loading any test data that it needs to load, and I'll typically just do that as plain old JavaScript objects that are part of the initialization of either the spec or the suite. Yeah, I don't think you've really got much in the way of tools to be able to load it easily from a file or anything like that. I certainly haven't concerned myself with expending energy on it, to be honest. Yes?
I noticed you put a large try catch around the text, which pretty much just cancels out the error. In your experience, do you find that after you're done creating the tests, you don't really ever encounter those errors?
So
does Jasmine have something that you just bring a hook in to say, you know what, it was a fail?
It's actually, I think that try catch was around because I uncovered an issue with the way I'd set Jasmine up, where if my test failed, it actually blew the Jasmine framework. So I did then fix the way that I set up my tests, but I just forgot to put that try catch around it to remove the try catch.
So then when Jasmine calls a function, does it automatically wrap a try catch around it?
Yeah, so it captures a stack trace. So when you get an error, you will get a call back to the reporter to say this test has errored, and you then get a massive, massive stack trace, which sadly will include some of the Jasmine information as well. So you do have to kind of dig down a little bit to see what's going on. But yeah, it will handle all that for you. It's just that I didn't know how to use Jasmine properly, and I forgot that one. This is how good my JavaScript is. Try catch around everything, because tell me what's going wrong. Something is, I know. Any else? Yes. Yeah.
How do you do that with Salesforce session?
So I use Selenium. So basically I've got basically a browser with Selenium, I can't remember what it's called, Selenium Server, I think. So that fires up the browser, does a login, it knows about the user ID and password. So yeah, it's not the most secure thing. It only runs on my local machine. I haven't got it in a server on the cloud or anything because it would expose too much information. But effectively, it's all being done through a browser that's being controlled programmatically. Yeah, so which is another reason I like the fact that you set up your tests in the browser, because trying to do that kind of thing, trying to control a browser quite heavily through Selenium is an awful lot of work. Whereas having the tests in the browser, I just kind of open one page, click one button, and I'm good to go. Any other questions? Yes?
Have you considered having these unit tests outside Lightning Components, like from Lightning?
So the question was, have I considered writing the unit tests outside of the Lightning Component framework and being able to do it in the command line? I haven't, because I typically want to be testing my JavaScript inside the Lightning Component framework. I think it would be possible to take your JavaScript artifacts and use those in something like a Node environment. Jasmine certainly works very well with Node. There wouldn't be any issue around that. But yeah, that wouldn't work for what I want. For my business logic is intended to work inside the Lightning framework, so I think that's a reasonable thing to do. I mean, I get it's not completely isolating the tests from all of the structures that may be involved, but for my use case, I think it's good enough for me. Any questions? If anyone does think of any questions, BrightGen, my company, have a stand in the expo, in the Salesforce campground, media and comms zone. So feel free to come over and talk to me about anything or ask me anything there. And I'll post the link to the SlideShare deck into the chatter feed of this session after we're done. Thanks very much for your time, everyone. Have a great Dreamforce.